This is the second part in a multi-part problem, and I'll just read the part over again if you've skipped directly, the question over again if you've skipped directly to this part. The table below, we're given a table of data, shows the number of hours per day 11 patients suffer from headaches. Before and after 7 weeks of soft tissue therapy at alpha equal to 0.01, is there enough evidence to conclude that soft tissue therapy works at reducing headaches? And on this video, we're going to find the critical values and the rejection region, rejection region under the curve. To find the critical values, we need a t-table, which we're going to use, which just about any statistics book will have. And if you don't have one in your book, you can look them up online. They're everywhere. They're all structured a little different, so be careful you know what you're looking at. But you need the significance level here. You need to know what kind of test you have, whether it's one-tail or two-tail test. And then you also need to know your degrees of freedom. We have 11 pairs of data. Our degrees of freedom is calculated as what is it, n minus 1. We have 11 pairs of data, so that's 10 minus 1. We have 11 pairs of data, so it's 11 minus 1. Degrees of freedom is 10. Let me get our little table here. Well, wait a minute before we do that. What kind of test is this? If your alternative hypothesis is greater than, if it's greater than, that means you have a right tail test. If your alternative hypothesis is less than, you have a left tail test. If your alternative hypothesis is going to be one of these three, is not equal to, then you have a two-tail test, both left and right. We have this first situation, because our alternative hypothesis was that the differences, the mean of the differences was greater than. So we're our A sub A was greater than 0, so that puts us in this first category, which means it's a right tail test. So we know we're dealing with a one tail test when we look in our table. So we look up under our table, 10 degrees of freedom, one tail. And we get a 0.01, 2.764. So our t sub 0 is equal to 2.764. Now what does that mean about the rejection region? Get rid of this. We have our t-test here, and we have found our t sub naught here, 2.764. So and it's a right tail, so this is our rejection region here. We reject in here.
And I know she just feels so.
And that is t is greater than 2.764. And that becomes our rejection region.